Hello, this is Wendy Lightheart, and today we're going to use the skills, laws, and properties we've discussed so far to learn a general approach to solving linear equations. Let's go over a step-by-step procedure which can be followed to solve any linear equation in one variable. First, if necessary, we need to simplify the algebraic expression on each side. There are a few things to look for when preparing to do this step. For example, are there any parentheses on either side of the equation? If so, we need to remove these parentheses by using the distributive property. Do we have like terms on either side? If so, we need to combine those like terms. Note that this is done separately on each side of the equation. Are there any fractions in the equation? If so, then we can eliminate them by multiplying both sides of the equation by the least common denominator. Once the algebraic expressions are simplified completely on both sides, we're ready to collect all the variable terms to one side and all the constant terms to the other side. And the last step to solving a linear equation is usually to isolate the variable using division. Then, if we obtain a solution to the equation, we can always check that proposed solution by substituting that value in place of the variable in the original equation. Let's use this procedure to solve a couple of equations. In this first example, notice that we have parentheses on the right side of the equation. So our first step will be to use the distributive property to get rid of the parentheses. We have a -8 that needs to be distributed. -8 times 2 is -16, and -8 times -x is +8x. Now we have like terms to combine, which leaves us with 20 equals 28 plus 8x. We need to get the constant terms together on the left side, because notice that the variable terms are already together on one side. And we can do this by subtracting 28 from both sides. This leaves us with one last step, and that is to divide both sides by 8 to get x by itself. Simplifying both sides, we obtain a solution of x equals -1. This next equation is an example of an equation that has fractions. Recall that we can eliminate fractions by multiplying both sides of the equation by the least common denominator, which means we need to multiply every term on both sides by 12 in this case. Notice that I wrote the 12s in fraction form since I'm multiplying it by other fractions. It just makes it easier to see the multiplication that way. When we multiply, notice that the results will all simplify to nice terms with no fractions remaining. Now we have an equation that's much easier to solve than the original equation. But remember that by the multiplication property of equality, it has the same solutions as the original equation. Next, we need to collect the variable terms to one side. Since there's only one constant term and it is located on the right side, we need to move the variable terms to the left side. And we do that by subtracting 8x from both sides. This leaves us with -5x equals 10. So now we divide both sides by -5 to finish solving the equation. And simplifying both sides, we obtain our solution, which is x equals -2. Now recall that if we obtain a single solution to a linear equation, we can always check to see whether the proposed solution is truly a solution to the original equation. So let's check to see if x equals -2 is a solution to this equation. We do this by plugging x equals -2 in place of all the x's in the original equation. And we want to know if this will give us a true statement. To answer this question, we simplify both sides until we obtain a single number on each side. If the numbers on both sides of the equation are the same, then we know it is a true statement. To add the fractions on the right, we must find the common denominator, which is 6. And we rewrite the 4/3 as the equivalent fraction of 8/6. Now we can add the fractions, which gives us -3/6, since -8 plus 5 equals -3. And reducing this result, we obtain -1/2, which is the same number we have on the left side. Thus we can see that our proposed solution of x equals -2 is a true solution to the equation. Yes. Let's look at a couple more examples. Notice that for this example we have parentheses to get rid of. So first we will use the distributive property, distributing the 2 to the first term and then the second term. And this gives us 2x minus 14 equals 2x plus 10. Both sides are now simplified, so we can work on getting the variable terms to one side, which we can do by subtracting 2x from both sides. Notice that the variables canceled out on both sides, leaving us with the equation -14 equals 10. Whenever in the process of solving the equation, the variable terms cancel out on both sides, leaving you with a false statement like this, it means the original equation has no solution. Let's look at one more. Notice that once again we have parentheses to get rid of, which we can do by using the distributive property. We distribute the 2 to the first term and then the second term. Now notice that we have like terms to combine on the right side. 3x plus 2x gives us 5x, and -7 plus 2 gives us -5. Both sides are simplified at this point, so we're ready to move the variables to one side, which we can do by subtracting 5x from both sides. Notice that once again the variable terms canceled out on both sides. However, this time we ended up with -5 equals -5, which is a true statement. Whenever in the process of solving the equation, the variables cancel out and you end up with a true statement, that means any real number is a solution to the equation. Thus we say the solution set is the set of all real numbers. Or in other words, the set of all x's such that x is a real number. Well, that's it for this lesson. Have fun solving!